equal to integration from 0 to pi by 2 1 upon 1 plus tan of x. As you can observe here, there are terms in first example you can see the terms are in trigonometric form only, but here is only tan x is there. So we simplify this integral first and then use the method as we used to evaluate integrations before this. So I take first trigonometric simplification. As the relation tan x is always put into sin x divided by cos of x. As there is a addition, so we take algebraic simplification by making common denominator in denominator by cross multiplication. So we get first numerator as a cos of x, second numerator as a sin of x, and common denominator is cos of x, which is at denominator. So we put it in numerator. So we get integration from 0 to pi by 2 with numerator cos of x, as 1 into cos of x is a cos of x, and denominator contain the term cos of x plus sin of x. Now see the change. As in given integral there is a algebraic term 1 and tan of x is a trigonometric term. Now in this integral we get only trigonometric terms in numerator and denominator. So put it as number 1, and now use by property x replaced here by addition of limit is now pi by 2 minus x. So I will become integration from 0 to pi by 2. In numerator we get cos of pi by 2 minus x, in denominator cos of pi by 2 minus x plus again sin of pi by 2 minus x. Now same allied angle formula we used here, as cos pi by 2 minus x is always sin of x, and in denominator we get sin x plus sin pi by 2 minus x as a cos of x is the second term. Now put this as a number 2. Now adding 1 and 2. Now the remaining procedure will be same, as we get 2i on left hand side with common limit 0 to pi by 2. We get integral 1 always. So integration of 1 is always x with limit 0 to pi by 2. So subtraction of limits we get, which is a value of 2i, which is here pi by 2. Now I is become pi by 2 by 2 is a pi by 4. So in next example also I is integration from pi by 6 to pi by 3, 1 divided by 1 plus cube root of cot of x. We make first algebraic trigonometric simplification by putting the value of cot of x in relation of sin and cos. Actually cube root of cot of x will be cube root of cos x, cos x divided by cube root of sin x. Now making common denominator by addition in denominator, we get integration from pi by 6 to pi by 3, 1 upon cube root of sin x in first numerator and plus cube root of cos x is the second numerator, having common denominator cube root of sin of x, which we take in numerators as it is in denominator. So we get integration from pi by 6 to pi by 3, as 1 into cube root of sin x is the cube root of sin x is in numerator. Now in denominator we get the term cube root of sin x in addition of cube root of cos of x. As now we can put this as integral number 1, and by property here also we replace x by, now replace x by addition of limit, lower limit is pi by 6 plus upper limit is pi by 3 minus x. Now pi by 6 plus pi by 3, actually pi by 6 is 30 plus pi by 3 is a 60, 30 plus 60 is a 90. That means pi by 2, as x is replaced here again pi by 2 minus x. So I is equal to integration from 0 to pi by 2, 0 to pi by 2 not is given here, pi by 6 to pi by 3 does not make change in limits. Now cube root of sin x is replaced by here, addition of limit are pi by 2 minus x divided by, in first term in denominator cube root of sin, again x is replaced by pi by 2 minus x plus cube root of in second term cos of pi by 2 minus x into dx. Now again by using formulas of allied angle, we get here I is equal to integration from pi by 6 to pi by 3, in numerator sin pi by 2 minus 6 is cos of x, so we get cube root of cos x. In denominator also, in first term we get cube root of cos of x, and in second term is cube root of cos pi by 2 minus 6 is sin of x into dx. Put this as a number 2. Now remaining steps are same, adding 1 and 2 we get on right hand side 2i is equal to from limits pi by 6 to pi by 3 1 dx. Actually 1 has the integration x with limits pi by 6 to pi by 3, so we take the subtraction of limit pi by 3 minus pi by 6. Actually pi by 3 minus pi by 6, 60 minus 30 is always 30. That means pi by 6, which is a value of 2i. So I is become here pi by 12. So answer is a pi by 12. So you can observe this is a subtraction of limit divided by 2. Now last example is similar to both, but we have to use here relation as a tan x in numerator, sin x divided by cos x, and in denominator we get 1 plus sin x divided by cos of x. Now making common denominator in denominator, so we take cross multiplication, as cos x will in multiplication of 1, so we get cos of x with common denominator cos, which will get cancelled. Now you can observe sin x divided by cos x plus sin x is the remain, which we have solved in second example. So this integral has also value as subtraction of limit is pi by 2 and divided by 2 is the answer, that is pi by 4. Evaluate integration from 0 to pi by 4 log of 1 plus tan x into dx. Now put it as a I and put it as a number 1. By property here, x replaced by addition of limit as 0 plus pi by 4 is a pi by 4 minus x. Therefore I is equal to integration from 0 to pi by 4. As we use property, the value of integration does not, so it remain I, and limits does not change, so it remains 0 to pi by 4. Only in integral we replace x by pi by 4 minus x here. So in integral log of a bracket 1 plus tan of x is replaced by here pi by 4 minus x, bracket complete into dx. Now you observe here we have to make here trigonometric simplification, as pi by 4 minus 6 is the angle of form a minus b, as it is a compound angle, and you know the tan ratio of compound angle a minus b is a take trigonometric tan ratio of both angle and subtract in it in numerator. So tan a minus tan b divided by 1 plus multiplication of both the tan ratio, that is tan a into tan b. Remember this form, and using this form we can here use trigonometric simplification. As we know here limit 0 to pi by 4 is given log of bracket 1 plus, here a is a pi by 4, that is means first angle is pi by 4 and b is x. So we take tan ratio of both the angle tan by 4 pi by 4 and tan of x and subtract them in numerator, and in denominator we take 1 plus multiplication of both the tan ratios. Now tan of pi by 4, actually pi by 4 is a 40 pi and tan pi by 4 is always 1, so we take the values of tan pi by 4 in integral. So integration from 0 to pi by 4 log of bracket 1 plus, now tan pi by 4 in numerator, in second term 1 minus second term as tan x is remain as it is, so in denominator 1 plus tan pi by 4 is 1 into tan x, we get the tan of x. Now we make the trigonometric simplification here. Here now in bracket there is addition, so we take algebraic simplification, as we take cross multiplication to make common denominator in this term. So 0 to pi by 4 log of, by multiplying denominator we get numerator of first term as a 1 plus tan of x, as second term has a numerator 1 minus tan of x, as divided by denominator 1 plus tan of x, bracket complete into dx. Now simplifying this, as we get in numerator tan of x get cancelled with minus tan of x, and we take only 1 plus 1 2 in numerator, and in denominator we have 1 plus tan of x. Now the algebraic simplification is over here. We take here logarithmic simplification also, as we know m by n with log is written by log of m minus log of n. The divisions the quotients log we take by taking subtraction of numerator and denominator's log. So here we get integration from 0 to pi by 4, integration from 0 to pi by 4 log of numerator, that is log of 2 minus log of denominator, that is log 1 plus tan x into dx. Now because of this logarithmic simplification we get subtraction in integration, and now by using rule of integration we take separate integration as with limit 0 to pi by 4. Now in first term we have a log of 2. Actually log of 2 is a constant, So we can take it outside integration. So log of 2 take outside integration from 0 to pi by 4, integral remain only dx, as operator is remaining only, and minus in second integration 0 to pi by 4 we get log of 1 plus tan of x into dx. Now you can observe here, integration from 0 to pi by 4, log of 1 plus tan x is given integration, which we have value put by I. So we take here I. So on both side, on left hand side we get I, on right hand side in first term we get log of 2 constant, and integration of dx is always x with limit 0 to pi by 4, and minus I on right hand side, which we can transfer on left hand side, but sign will change. So on left hand side we get I plus I s, and on right hand side we get log of 2, as x is there, so we take only subtraction of limit as pi by 4 minus 0. So 2i is equal to, now pi by 4 minus is 0, so we take pi by 4 into log of 2. Now this 2 is transfer on left hand right hand side in denominator, so it take in multiplication of denominator, so we get pi by 8 into log of 2. So answer I.